All right, so tomorrow we have our written test number 1, and it will be during your lab session. As for the start time, it will be a little bit different from your programming test, so please do check the guide PDF about when your test should really start according to your enroll session. Okay, you can look at the guide. It has been released ever since the study week. Take a look. And the review session from yesterday, we also released the material. You can check the lecture site. I also make an early announcement just before the class. You can take a look. And don't forget, you also got your lab number 3 to be completed, right? If you got any questions, you can also ask the TA. You can find their contact information on the e-class, or you can reach out to me during my office hour. Okay. All right, any question about the course? All right, let's now do a very quick recap from last time. Oh, just before that, I want to clarify something very quickly. And of course, the guide has not been changed. It's been consistent. So we said that for your object equality slides, which I'm still going through, you are supposed to study up to and until, including slide number 19. So on Monday, we were basically still actually talking about the contents, from slide number 91 to 19, but you already got a slide. So that's something I would expect you to already have studied before the test tomorrow. But still, today we'll still do a little bit of discussion about this range over here that could be to your advantage, which is clarifying some concept and also do more example just to show to you, right? But the range for the coverage will just be the same, okay? That's what you got to study up to for the test tomorrow. All right, let's now do a very quick recap from Tuesday. And then we'll continue. All right, so on Tuesday, the most important thing is really about this example here. We try to introduce to you about intuitively what a static type is, what a dynamic type is, and what a typecasting is. We're going to dive into more details about each one of these when we talk about inheritance a little bit later in the course. So static type is really what a variable is declared to be. You can never change the static type of a variable once it's declared. And the static type is going to determine the range of attributes and methods you can call on that particular variable with the declared static type. That's the most important facts you should really know. As for the dynamic type, it's going to determine the version of the method you're going to call, especially in our context for now. We have the equals method, which may come from either, let's say, for our point example. So the version could be either the default version from the object class, or it could be the version from point v2, right? So these are two versions. Which version should be called really depends on the dynamic type. And the way for you to trace the dynamic type is whenever you draw the objects, the title of the box is really the dynamic type, which may change from time to time. And the typecasting over here is to say sometimes the static type for the variable you declare may not allow you to call certain methods. For example, if you declare the variable to be of static type objects, you will not be able to actually call things like a x and y that might be only callable on point v2, in which case you may have to do some typecasting. What the typecasting does, it does not really modify the static type of any variable. You can never modify that, right? So what the typecasting does is, given this particular object here, the existing reference has certain static type, which you're not so happy about. What I want to do is, I want to refer to the same objects. I want to create an alias. But the alias has a different static type, T2. That's a cast type. With the T2 being the new static type for some other alias, I will be able to call the attributes or methods on this particular dynamic type. That's really something we went over in very much detail on Tuesday, right? I may not repeat the details, but that's something you guys should really go over very thoroughly before Friday's test tomorrow, okay? And then later on, we're going to talk about each one of these, static type, dynamic type, and typecasting in a much more generalized fashion. So not just about equals method, but mainly just in general, the inheritance hierarchy. That's something we'll get into a little bit later. All right, so we talk about this phase number 3 about the get class. So the get class will simply return the dynamic type for particular objects, right? So for example, it could be this, could be that. If you're comparing two objects of different dynamic types, in that way, it should just return false. You cannot compare apple with banana. No way. Okay? It's a category error in some way. And then phase number 4, we talk about if we are able to reach phase number 4. That means we got all these 3 conditions satisfied. How did I derive these 3 conditions? You got to think about the branching condition for phase number 1, the branching condition for phase number 2, and the branching condition for phase number 3. All of them are false. Otherwise, I would have returned true or false already. If I didn't really get any one of them satisfied, I would reach phase number 4, right? Logically, you really want to think it through. So if we're able to reach phase number 4, what we do is we try to cast the OBJ, the parameter, with the static type objects. With the static type objects, you can call very limited range of methods with objects. But if I know that OBJ dynamically is really pointing to point V2, so I can now cast that into another alias over here called other with a static type point V2. In that way, I will be able to call X and Y. So that's why you can see other.x, other.y, other has a static type point V2. On the other hand, as I explained last time, if you say obj.x, obj.y, it will not compile because it has a static type objects, right? This kind of like a story you want to really get yourself understood, right? Of course, don't memorize it, right? All right, any question about this? All right. Okay, and then we talk, that's just an example. You guys can go through, pretty straightforward. All right, and then we talk about short circuit evaluation. I'll give you guys a little bit more clarification and example. You can also refer to the review recording. I think Judy also did a very good job explaining that in the last practice question. You guys can take a look at that and also combine with what I'm going to say today as well. I just want to give you guys more exposure to short circuit evaluation. So we talk about in math, you got conjunction, disjunction. In Java, you also got ampersand, vertical bar. They are not exactly equivalent to each other. And the main thing is really about commutativity. In math, it does not really matter the order of the evaluation. However, in Java, which is a programming language, it does matter. Whether you evaluate P first or evaluate Q first, you may have some possibility of throwing some exception from either of the expression. So the way you kind of organize the conditions for left and right, it does matter. Okay, I'll give you some example very soon. That's really the essence about short circuit evaluation. So we spoke about this one here in detail on Tuesday. So in the case of ampersand, you got, of course, this is a truth table you all know about. We know that the only way for us to get true for ampersand is when both of them are true. That means if you want to evaluate some expression here, let's say ampersand, I got expression 1, I got expression 2. I should only need to evaluate expression 2 if I have evaluation of E1 being true. If E1 is already false, there is no need to evaluate E2, right? That's something we said about. You don't need to. So what we typically do is we have some constraint over here as a guarding constraint. I'll say a little bit more in just one moment. Okay? And then we talk about the order of evaluation. You always go from left to right. Always evaluate the left-hand side, and then, if necessary, you will go for the right-hand side. All right? Let me say very quickly about disjunction as well, and then we'll take a look at some example. So for disjunction here, all you got to notice is there is the only way for you to get false for vertical bar is when both operands over here are false. If either one of them or both of them are true, the result will just be true no matter what. So here is the rule accordingly, kind of symmetric to the short circuit evaluation for conjunction. Okay, I'll write down the rule over here. So when you actually have to evaluate, let's say, if I want to evaluate expression 1 or expression 2. Principle number 1, the evaluation is going to be from left to right. So I got to remember, I got to evaluate from left to right. Evaluate this first, and only evaluate this when absolutely necessary. Okay? So let's now talk about different possibility. So possibility number 1, I'll say 2.1 here. So you evaluate the left-hand side. Evaluate expression 1. Expression number 1. And let's say that one evaluate to be true. If this is already true, I know that according to the truth table, if I already got true over here, it doesn't matter what the second operand is. It will just be true no matter what. So I don't need to bother. with the second expression. All right? In that way, I know that I can simply I can skip the evaluation of expression 2. And also the overall result for the disjunction will just be true. All right, that's case number 1. Case number 2, if I evaluate expression 1, it happened to be false. If I evaluate expression number 1 and it tells me it's false, let's look at the truth table, right? If I got false over here, in that way, if the second operand is false, it might be false. If that's true, it will be true. So it really depends on what the second operand is. So I still have to evaluate it. I cannot skip it, like in case 1. Right? So you have to evaluate expression 2 to decide. Right? So the way we can structure about the evaluation and also result over here is just symmetrical to how you handle %, So the short circuit evaluation is for both the %, and also vertical bar. Right? Any question? Okay, I'm going to summarize very quickly about the rule in general, but you can also take a look at this example here, for example, right? Let's say I just choose 1 here. Let's say if I got this particular value over here, let's say currently x is 0 and also y is 10. And I have this expression over here to evaluate. Okay, let's think about this is the left-hand side for the disjunction, and this is the right-hand side of the disjunction, right here. And I'm assuming that currently x is 0 and y is 10. So x is 0 and y is 10. Right? If you think about the right-hand side here, if I ever have to evaluate 10 divided by 0, I'm going to have some exception, like a division by 0 exception. But I want to avoid having to evaluate this. How do I avoid it? I got some expression here on the left-hand side for the OR. So here I got 0 equals 0, which will be true. So that will be case number 1. Because if this is true, I can skip the evaluation of this. Right? So I don't really ever have to go for this one here. All right? All right, so this one here is going to be true. That means we avoid or skip evaluates 10 divided by 0. Right? That's how you can see this particular evaluation. And you can also give it a try maybe on another pair of x and y. Right? And the order is very important. If you actually you kind of swap the order. Let's say if this is 1 and this is 2. But if you say 2 or 1, it's not going to work. Because the order of evaluation will be from left to right. If you evaluate this one first, you got to evaluate 10 divided by 0 first. You're going to get the division by 0 exception right away, right? So for short circuit evaluation, the order of the constraints are very important. Okay? So let's now do a very quick summary about what you should really watch out for. Okay? Just in general, when you want to kind of design your Java code according to short circuit evaluation. Okay, so for short circuit evaluation, okay, let's talk about both the conjunction and disjunction. Okay, that's number 1 and number 2 over here. Okay, basically we got either the %, or we got the vertical bar. What we want to specify carefully is the guarding condition over here. And I'll talk about these in just one moment. We want to somehow protect what's on the right-hand side, okay, expression 2. So expression 2 is something we want to avoid when there's a danger of throwing some exception. Okay, expression 2 over here. And the typical exception you want to avoid will be something like if I got y divided by 0, right, division by 0, if the denominator happened to be 0. And also if I got array indexing, array index out of bound exception, that's the one in your practice question, right? I should be valid. Another thing could be, let's say if I want to call obj dot certain method, I want to make sure obj here is actually not equal to null. So I can avoid null pointer exception. So it's either division by 0 exception, division by 0 exception, or it's the array index out of bound exception, which we have seen, and also the null pointer exception. So these three are the typical ones you want to avoid, right? There might be others as you get more advanced, right? So expression 2 should really appear on the rightmost end for the operator, basically. Anything that happened before that should be somehow serving to evaluate first and decide whether or not we should really evaluate the right-hand side, okay? So let's talk about each case. So this part over here, expression 1, is something we call the guarding constraint. We are going to specify we're going to specify the Boolean expression here. If it is false, then we are going to avoid evaluating the expression 2. For example, let's say here, let me just say that's x. I just use our example on the slides. Okay? So in here, the guarding constraint will be x not equal to 0. Because if x happen to be 0, 0 not equal to 0 is going to be false. In that way, this conjunction here is going to be false anyway, so we can skip the evaluation by having x being 0 as a denominator, so we can avoid the division by 0 exception. Okay? So this will be the guarding constraint. But in the case of disjunction there, you cannot just copy the same Boolean condition there, because even though they are kind of related, but they're not exactly the same. Okay? So over here is what we call an error condition. Error condition, which I will also call expression 1. Error condition in the sense that if this Boolean condition here evaluated to be true, I know that there is some potential error. So I should not go ahead and evaluate expression 2. And that goes nicely, because if this is true, the OR will be true anyway, so I can skip the evaluation for expression 2. Let's say for the same example here, I'm going to specify instead x equals 0. This one tells me that if the x value happen to be 0, then I might have error for division by 0. So if x is exactly equal to 0, I'm just going to skip expression 2. Okay? So think about expression 1 here and expression 1 here. They are the logical negation of each other. One is about guarding, the other one is about specifying error. Right? Think about this kind of logic here. So depending on which operator is being used, you want to know how to specify the condition on the left accordingly. Okay, let me just make a final remark here. This one here, and also this one here, they are not exactly the same, but they are closely related. Okay? So they are the logical negation of each other. Negation of each other. All right? So if you already specify something over here, what should be the corresponding one? It should be the logical negation. All right? Everything we're talking about now is a very like a practical application of some logic. And the logic is based on the truth table for the conjunction and disjunction operators. All right? Any questions? Yes.
So just to clarify, so for the and,
Yep.
it's supposed to be x is not equal to 0.
Yes. Yeah. So thinking this way. Let me just recap. I like the question here. Let's say it one more time. Let's say expression 2 in both cases involve y divided by x. Let's say we don't really want to do anything when x happen to be 0, right? Now we can avoid having to evaluate y divided by 0 in two possible ways. In this case over here, we want to make sure this condition here will evaluate to false when x is equal to 0. We want to say x should not be equal to 0. Otherwise, we get division by 0 exception. Now, in this case, 0 not equal to 0 is going to be false. So we don't really bother with the right-hand side. And for this one here, to avoid it, we're going to specify something that's logically negated. So in this case, we want to say, if x happen to be 0, in this case, yes, 0 equals 0 is going to be true. And for or, if this is true, we also don't evaluate this, right? So in both cases, by specifying these two logical conditions correctly, you can usefully avoid having to evaluate expression 2 to avoid the division by 0 exception. Okay? Of course, you guys should really think about how to avoid array index out of bound exception, which would be kind of relevant to your practice test. And this one here is just about the context object here being not void, right? Think about these. They're all relevant. Okay? I think this page is really worth reflecting. Very practical knowledge for you to know. All right? Okay, that's good. And then let's now talk about, okay, so I also got one page over here just about like a common error. Okay, why don't we go over one of them together? Okay, let's see this. Let's say we talk about conjunction, okay? So let's say we now talk about conjunction over here, and we got two parts. Part number 1 and part number 2, right? Again, we are using the division by 0 example. So here, I got y divided by x, which might get division by 0 exception if x happen to be 0. And now I'm specifying the guarding constraint x not equal to 0, which seems to be correct, right? You can see x not equal to 0, what I just said. However, is this going to work at runtime when x is 0? No, because remember, when you talk about short circuit evaluation, the order of evaluation also plays an important role. So let's say if x really happened to be 0, in that way, the evaluation is going to be from left to right. That means we're going to evaluate this one here first. We're going to evaluate 10 divided by 0 larger than 2. Unfortunately, you're going to get division by 0 exception right away. And you don't even get a chance to check the guarding constraint, which is not very good. Right? You want to make sure the guarding constraint, if any, should be checked first before the expression itself you want to protect. Right? All right, you can do something very similar for the or example as well. Right? Similar. Okay. Right, any question? Let's do one more example, right? Shall we? What I want to do is, I want to now talk about the equals method. And especially I want to just copy the code over here, and then I'll put it here. Okay, right here. So this is the 4 phases that we actually spoke about. Okay, let me just make sure I copy that properly. There you go. There we go. Okay, right here. Okay, I'll make it a bit larger. All right, so that's the equals method we spoke about in detail. Now I want you to focus on phase number 2 and phase number 3. Okay? Specifically, I want you to look at a branching condition. So phase number 2 is right here. Oh. Phase number 2 and also phase number 3. All right? The reason I want to talk about it is we want to think about the possibility of making the code a little bit shorter. Because you can see that in both cases, we are returning false. Right? Why don't we combine them? We want to say either case 1 or case 2, we're going to return false. Rather than saying case 1, return false, case 2, return false. Right? This is a very obvious place to really use a logical operator. And I can tell you that we may want to use the or operator. We want to say either this is the case or this is the case, we're going to return false. Okay? So we're going to combine these 2 lines into a single line. I will write down 2 possible solutions. You guys can tell me whether both of them are going to work, or maybe some of them are not going to work. We want to simplify this into 1 line. Okay, simplify. And just to save some writing, so let's say this condition over here, obj equals now, let me call that condition 1. Okay, and then this long expression here about the dynamic type being different is condition 2. All right, 1 and 2. Okay, I got 2 options for you. Okay, option A and option B. Option A, I would say if I'm going to put the OR here and then return false. Okay, let me write down the skeleton first, and then I'll fill out the specifics. Or return false. Right? You can think about the return false just correspond to what I highlighted right here, right? Okay. Option A, why don't we say 1 or 2? Option B, 2 or 1. Okay? And let's say this one here is more like a multiple choice. Select all the implementation that's going to work. What will be your answer? Anybody? Yeah, go ahead.
Just option A, because option B could get a null pointer, because if all OBJ get class objective object is null, OBJ get class will be null, and return null.
Very good, very good. Yeah, what your fellow student is, just said was spot on. Let me just repeat that, okay? So this one here, just emphasize again, when you want to think about logical operator in Java, order of evaluation is so important, right? So basically, the answer is this is good and this is not good, all right? Let's talk about why this is not good. If you think about the order for this one here, it's going to be from left to right. That means this is going to be evaluated first. When evaluating this. Number 2, what if OBJ itself is actually null? In that way, you got null pointer exception. Null pointer exception if OBJ equals null. But why would option A not have this issue? It's because 2 is put before 1. So 1 here is more like an error condition. So 1 here is checking right away whether or not OBJ equals null. If it is equal to null, this is going to be true. Once this is true, we don't evaluate this one anymore. So we safely guard it. All right? So that's a justification. And I think if this is a multiple choice, yes, you got to make sure you choose A only. If this was in the exam, you will have to know how to express yourself about the rationale that either your fellow student or myself just said, right? It will be something we expect from you in the final exam. So do practice about, with your classmate about explaining why things work and why things do not work to each other. I think it's a very good training for you guys as a computer scientist or engineer, okay? All right, any question about this example here, right? Just another simple application of the short circuit evaluation. Okay, I think we also got this another exercise about short circuit evaluation in your slides, but that's for later, right? That one's not really covered in tomorrow's test, but it's definitely important. But I'll mention that a little bit later. All right, let's not just go on with this comparison here. This one here, nothing new. We have already talked about the only point V1 where we call the default version. And also we got point V2 where we call the overridden version, right? I'm just trying to, I want to compare and contrast them once more for you to see, okay? For these 2 fragments of code, I want you to look at line number 10 over here, and also line number 10 over here, okay? Especially, I want to focus on deciding which version of the equals method is going to be called. If you remember the recap I just said today, which type, static type or dynamic type, is going to determine the version of method being called? Static or dynamic? So important. Take a guess. If you don't remember, huh? Static? No. All right. Guys, this is so important. All right. Whenever you want to determine which version of the method that should be called, in this case, equals method, you should look at the dynamic type. All right. Let's take a look. Especially, you want to look at P1 over here and also P1 over here. You want to look at its dynamic type. Dynamic type. All right. Once you determine the dynamic type for the context object, you would know which equals is going to be called. It could be the equals from the objects, or it could be the equals from the customized, like overridden version. What about this one here, right? You can see P1 was created here, right? You can see new point V1, right? 2, 3. So that means 2, 3. So this is the dynamic type, the title of the box, dynamic type. So once we know that the dynamic type is actually point V1, okay, so I'll put it here. So for the start, dynamic type of P1 is point V1. And if you look back, point V1 does not override the equals method. So we got to use the default one. The default equals from the objects is invoke. All right, that's the first remark. And then if you look at this one here, where is P1? So P1 in this case was declared and created right here. That one there you can see it's a point V2 constructor being called, right? So you can see P1 here will be also 2, 3. The title of the box is the dynamic type. So I'm going to say star star over here. Because dynamic type is point V2, so we know that a different version, specifically point V2, has the overridden version over here, right? So this version here instead will be called dynamic type of P1 is point V2. The overridden version is invoke. All right, one more visual. Think about this P1 over here has this dynamic type. So it's going to call this version of the equals. And this P1 over here has the dynamic type point V2. So it's going to call this version over here. Right? So you have to make sure you always check what's the dynamic type for the context objects. And then determine which version is going to be invoked accordingly. Right? It's something we actually said, but we never actually put the two scenarios side by side. Hopefully that helps. All right? All right, so this is another exercise we can do. Let me see. Okay, let's now do one more, and then we can take a short break. What? Just 5 minutes or so. Okay, and this would correspond to. Let me see the slides over here. So this basically corresponds to slide number 18, which is something you should have already studied, right, for the test. Now I just want to also go over that with you. So we got two notions of equality, either reference equality, in which case you just use the equal. So we talk about reference variable, right, addresses. And also we talk about reference equality, comparing addresses, and also about object equality, in which case you may have some overridden or redefined version of the equals, comparing x to x, y to y, right? And then, so we have the following question, a little bit more general, okay, right here. So let's say we got point V2 that has the that has the overridden version, right? Just put it as a reference for you. Let's consider two statements over here. We got statement A and statement B. Okay? If I tell you that two objects are reference equal, what does that mean? First of all, two objects, obj1 and obj2. If they are reference equal, they're the same objects, basically, right? Just the same, literally, the same address. So I will have obj1 equals obj2. That's what it means. That's statement A. If I know that as a Boolean condition. And for B here, two objects are content equal. So when I say content equal, that means I kind of see beyond the addresses. I want to see what's actually the contents, maybe x to x, y to y. And this one here, I'm really saying if I try to say obj1 dot equals, and then obj2. This is a Boolean method call. Let's say that returns true. That's what I meant by content equal. Let's now get something logical, right? So you guys learned back in your logic course, either P this Q or P arrow Q. You know what that is? Implication, right? That's something you should have learned in the first year, right? About logical implication. If P is true, that tells me that Q is also true. All right? Logical implication. If doesn't ring the bell, you should really look it up and make sure you brush it up. That's actually important. Okay? It's a logical implication. All right, so now we have, again, multiple choice. And this one here, I can tell you that only one answer is right. Okay, think about it's more like a radio button here. Okay, either this or this. Okay. Option A. If two objects are the same objects, then their contents are equal. Okay. So this one, if you want to phrase that a little bit more formally, it would be something like A implies B. Option B, the second option here, if the contents of two objects are the same, that means they are the same objects in terms of their address. Okay? So this will be B implies A. Now I got two choices for you. Only one of them is always the case. Okay? Anyone? Go ahead. The first one is always true. I agree. So you're saying that if the two objects over here, okay, the first one, let me justify that very quickly. It turns out this is actually true, and this is not always true. I can give you some counter example to show that. Just one moment, okay? And for this one here, your fellow student was actually right. For this one here, let's visualize it. If A is true, that means you got obj1 and also obj2. They are pointing to the same objects. If they are pointing to the same objects, it doesn't really matter how you define the equals method. You're just comparing the same objects. So it should always be equal to, right? So once A is true, it doesn't matter how the contents equal is actually defined because you're comparing one object to itself. So it will just be true. But what about this one here? Why is this one false? In order to show that this one is actually not always true, okay, so I'll just write down something here for you. Okay. Okay, the second option here, not always true. Not always true. And to really show that, I want to give you one example where the contents is the same. However, they are not really the same objects. And for logical implication, right, just for your information here, when you talk about implication, there is a rule in the truth table. If you got true implies false. If I can show you that true is for A, true is for B, and also false is for A, in that way, the implication itself would be false. Okay? It's equivalent to false, right? That's the logical base I have, right? So I'll show you that, okay? So now I want you to take a look at two lines in the example code here. I want you to look at line number 7 and also line number 6. Okay? These two, right? Think about line number 7 over here is checking to see whether P1 and P2 are content equal because you're calling the equals method, right? And this one here, if you look at P1 and P2, so P1 and P2, they got 3 and 4, 3 and 4. Content equal. 3 is equal to 3, 4 is equal to 4, right? So this one tells you that B is true. Okay, so this one is true. However, what about A? If A tells you that their reference must be equal always, is that the case? Not in this case, because P1 and P2, they are created using 2 new keywords. So they are not really the same. So what we're having here is some, let me just write it down first and I'll visualize that. Okay, number 6 over here, that one tells you that A over here is false, right? If you visualize it, it goes like this. So we got P1 and P2, right? P1 points to some point V2 objects where x and y is 3 and 4. And P2 is just another object, point V2. You got x and y, 3 and 4, right? So if you think about it, checking for B, content equal. 3 and 3, 4 and 4, they are equal. However, it's not necessarily always the case that A is also true, which means they are reference equal. Because if you look at P1 and P2, you have different references, right? So this implication doesn't hold always. This might be a slightly more challenging example here, since like you guys haven't really maybe brushed up with the memory about the implication. Look it up, and then let me know if you got trouble understanding it. This is important, okay, to understand the logical relation between the two different statements. Any questions before I move on?
So, Professor,
Yeah.
the answers from line 4 to line 9 would be the first one is true.
Yeah, so for individual line over here, you can definitely look at the slides. The answer is there. So I'm just saying that in order to show that this option here is not true in general, the way I show to you is I show you that B over here, content equal, is true. However, A here about reference equal is not necessarily true, consequently. So that's kind of, I show that implication is not true in general. Okay? So recap. So when you study for this particular example here, number 1, review logical implication. Right? Number 2, we are considering 2 kinds of equality. We're talking about reference equality, just about addresses. We talk about contents equality, that's about equals method, that's overridden. And then we say that if you got reference equality, then you must have content equality. On the other hand, in general, if you only know that you got content equality, you cannot say that you always got reference equality. Right? So that's the conclusion. Alrighty. Okay, this is good. I want to say one more thing, which is on slide number 19. Okay? That is something you would have seen, but I want to say that explicitly, quickly. On slide number 19, this is what you will see. So these are the principles you want to bear in mind whenever you want to define your own equals method, but they're quite rather straightforward. I want to talk about the first one here. Right? This is to say, whenever you got any object x, you want to make sure x dot equals, you pass on null reference, should always return false for that equals. Right? Well, that was easy to see because when obj equals null, we know that it should return false unconditionally, right? That really corresponds to that second phase. That's something I want to stand out and show you quickly. Okay? So whenever you got x dot equals, and then you simply pass the null reference, you should always return false. Okay? For that one, you can look at phase number 2. When obj equals null. And this is so important, just to remind you, this should evaluate false. Otherwise, Because we know that x cannot be null. So x over here is something not equal to null. If you compare something not equal to null with something that's null, of course, it should always return false. Okay? Otherwise, if x is equal to null, otherwise, you got null pointer exception. Right? That's kind of the logic we already mentioned when we discussed phase number 2. I think it really deserves some repetition here. Okay. Okay. Any questions? Go ahead.
So just to confirm, when you are checking for an object that is of reference, how do you check if it is equal to none? You say
Yeah.
because if it is none, it's going to give you a non-pointer exception.
Right. So you mean the x here or the null here? Which one?
So let's say x was a string, right? It's a variable for a string. If you want to check if it is equal to none, how do you?
There are different ways you can do it. Okay, good. So approach number 1, I can say if x not equal to null, and then if it is not equal to null, and then I can safely call x dot equals something, right? So when I am able to reach this body here for the branch, I know that it's guaranteed x is not equal to null. So I cannot get any null pointer exception. Okay, now that you ask, for everybody's benefits, okay? Another approach, short circuit evaluation. Ampersand, ampersand, and then I want to call x dot equals null. What guarding constraint should I put over here so that when x happen to be null, I can safely avoid having to evaluate this? What should I put here as a Boolean condition? Should I put x equals null here or something else? It's a logical puzzle, isn't it? Anybody? Okay, I'll leave this as an open-ended question. You guys really have to think it through. Okay? If I specify x equals null, is it good? All right? Based on our discussion so far today, with the example, you should be able to answer this. If you haven't been able to, maybe study a bit before you revisit this. All right? I really want you to think about it rather than just giving you the answer. Because in the exam or in the test, I might give you something slightly different. So you really need to grasp the principle to get it. All right? And of course, once you think it through about conjunction, can you also change this one to be disjunction? And what should this be if there's a disjunction? Right? That's another third approach. Right? That's really back to your original question. How can we make sure x is actually not equal to null when you want to use it as a context object? So there are different ways. Right? All right, all good. Why don't we take a short break by taking attendance, and then we'll resume. Okay. Again, your written test is going to be up to and including slide number 19, right? It's just being being already said. All right, let's now talk about something new. Okay, we just want to see how we can apply the object equality concept into JUnits. They do have some assertions that have to do with the equals method, and you can take a guess, what it is. Just assert equals. So now we can say much more about assert equals. You got to be very careful about what you pass to the assert equals, especially when you say assert equals P1, P2 versus assert equals P2, P1. They might behave differently. All right? So, got to be careful. Let's now talk about it, and you can look at the slides for later. Again, starting from slide number 20, as said in your test guide, it's not going to be covered tomorrow, but definitely it's important for the lecture as well. Let's talk about it. Okay? I'll just use my iPad, just to go over, fragment. Okay. Okay, let's now talk about one assertion there called assert same. So this one here, you're expecting to see two reference variables or reference expression. So this is really for references or addresses. So whenever you got expression 1, expression 2, so these two are two references, it really boils down into you just want to compare. For example, this one here, you just want to compare whether or not expression 1 and expression 2 contain the same address. If they contain the same address, let's say if this is true, then you pass. And if this is false, you fail the assertion. Right? As easy as that. Right? And of course, you can rewrite this assertion here. You're really comparing equals equals. If this is true, then you pass. If you flipped the logic here, you can also say they are not the same. Right? Think about this one here. I'll let you think. Right? We talked about assert true versus assert false before. Right? You can think about it. Okay? So this will be some exercise for you. Why does this work? Okay, let me recap very quickly. When you actually got assert the same, expression 1, expression 2, it will be as if you're doing this or you're doing this. All the three are equivalent. Okay, exercise for you to think about why. You got to put exclamation mark right here. Right? And let's do some example very quickly. Okay. Let's say we got P1, P2, P3, right? Assert the same, okay? So we can draw some diagram just to help you trace. So P1 and P2 must be different addresses, right? They are different calls to the constructor. So we got P1 over here, one object here, and P2 also another different object here, and P3 equals P1, right? So that means P3 is going to point to wherever P1 is pointing to, right? That's the objects after the three lines, right? When you say assert the same, right? Pass or fail, right? P1, P3, assert the same. Pass, same objects. P2, P3, P2, P3, different objects, fail. All right? As easy as that. So this one here, P1, P3, same objects. This one should pass. And the second one there, P2, P3, different objects, so they should fail. All right? So assert saying really not much to say. Just got to remember, it's really about comparing addresses. Nothing involving the equals method just yet. Okay? Let's talk about assert equals. And let's talk about simple case first. Whenever you say assert equals, you got to pay more attention to what types of expression you're comparing. If in the simple case, you're only comparing primitive. Let's say if you got two integers, I and j, and you say assert equals I and j. Well, just comparing their values. It will be as if you're just using equals equals for primitive, right? Just comparing value. Nothing about reference. You're just comparing values. Right? So in this case, I and j not the same, so fail. Right? Any question so far? Pretty straightforward. Let's now dive into the tricky bits. What if I call assert equals over here, but expression 1, expression 2, they are reference types? All right, so this will be the tricky bits we're going to talk about. Okay, and let's now talk about. Before that, let me just give you some very quick some tips or principle, and then we'll get to do the example. Okay. So let's say whenever you got assert equals, and then you got expression 1, expression 2. And our assumption for now is expression 1, expression 2, they are not primitive, right? Expression 1, expression 2, let's say they are reference type. And by the way, when I say reference type, I don't really imply they are the same type. It's okay. We can compare point V1 and point V2. We can compare point V1 and string. We can compare vaccination and distribution, right? I'm just saying they are reference type. The principle goes like this. And the order is very important. argument number 1, argument number 2. This boils down into argument number 1 dot equals argument number 2. Just remember that, okay? So this will boil down into expression 1 dot equals expression 2. First of all. And then the follow-up question will be, which version of the equals method is going to be called? It could be maybe the version default from the object class, or it could be some overridden version. So what will be your response to that? If I say assert equals boils down into expression 1 dot equals expression 2. So now how can we determine which version of the equals method is going to be called? What should we look at? Huh? I like dynamic type. Okay, that's great. Okay, who's dynamic type? Should we look at the dynamic type for expression 1 or dynamic type for expression 2? Expression 1, the context object, right? Yeah, that's good. All right. Here, the version invoke depends on expression 1's dynamic type. Dynamic type for expression 2 does not matter. All right? Dynamic type, not static type. So that means you got to trace the code to see what the dynamic type is for expression 1. Right? That's the most important principle. And all the examples we're going to talk about later are going to relate to this. Okay? Let's now do a little bit of mental exercises before we see some concrete example. Okay? Consequently, I'll give you two scenarios here. Let's say if I put assert equals, and then over here I put expression 1, expression 2. Right? Number 2 over here. Assert equals, and then I say expression 2 followed by expression 1. Right? You can notice what the difference is, right? This one here, pass or fail. This one here, also pass or fail. Are the pass or fail result between these two always consistent, always the same, or not necessarily? Based on what we just said in the definition. What should we look at then? Because assert equals somehow ultimately is going to cause the equals method. But which version? Right? Are we going to end up calling the same version of the equals method for 1 and 2? Or not necessarily? If not necessarily, it depends on what? Right? So this one here, okay, I just want to make sure nobody wanted to speak. Okay, so this one here boils down into expression 1 dot equals expression 2, right? By definition. This one here boils down into expression 2 dot equals expression 1, right? The version of the equals that's being called for this case depends on the dynamic type of this one here. And for this one here, it depends on this, expression 2 dynamic type. If they have the same dynamic type, yes, the same equals method will be called. But if expression 1 and expression 2, they happen to have different dynamic type, for example, point V1 versus point V2. In that way, different version of equals method will be called. Right? So it really depends. Okay? So now here, equals from expression 1's dynamic type is called. And this one, the equals from expression 2. Dynamic type is call. Right? So just notice that the order of the arguments that you pass to assert equals really matter, simply because this one here will turn into this. So only the dynamic type for the context object matters. All right. Any questions about this? All right. Let's now do some quick example, okay? Quick one, and then we'll do some more complicated one. Okay? So this one here is the principle I just explained, okay, about expression 1 equals expression 2, okay? Let's now take a look. Let's say we got point V1, also we got point V2. Of course, dynamic type is here, right? So just remind you over here, so these are the dynamic types. They want to keep track. So these are the dynamic types. All right. Let's now, first of all, just visualize P1, P2, and P3, okay? So P1 points to an object of type point V1, okay? And P2 points to another object of the same dynamic type. So point V1 as well. And P3 points to another object here, but as you can see, the dynamic type is point V2, right? Let's now highlight the difference. We got point V1, point V1, point V1, point V1, point V2, point V2, right? Dynamic types. And then we're just going to see here, assert equals P1, P2, right? This one here, which version of the equals method will be called? From where? Whose dynamic type should we look at? P1 or P2? P1? If I look at the dynamic type for P1, it's point V1. And point V1 does not have the overridden method for equals, right? So we should look at the object version, all right? So P1 over here has the dynamic type point V1, okay? So let me put a star over here. So the star here. So the object version will be called. And the object version here will simply boil down into comparing the references. You just boil down into P1 equals P2. Right? In that way, P1 equals P2 will just be false. So we're going to fail this assertion. So they are not equal. Okay? So this one here is actually going to fail. Okay, of course, this will be false, right? Okay. You can think about we are doing these two independently. So we kind of, one fail, we can just see another one, okay? But of course, in the actual execution, once the earliest failure is going to cause the whole program to terminate, right? It's a different story, okay? Let's look at this line here independently. If I got assert equals P2, P3, right? I should look at only the P2's dynamic type. So now I look at P2 over here. The dynamic type is also PV1. Agree? Same. PV1. Now, which version of the equals method should I call? Still the same. So happen to be the same. Okay? So now if I look at star, star, okay? Because P2's dynamic type is also PV1, so we are still calling the object version. But there is a subtle difference over here. We're comparing P2 equals P1. Still false, right? But it's a little bit different, right? You should really know the 100% detail, right? So this one here also fell. Okay? For a slightly different reason. One is because P1 equals P2 is false. The other one is because P2 equals P1 is false. Okay, not exactly the same. Okay? And then the next one there will be the case where by using different order of the arguments for the assert equals, you might call different version. That's we can look at some example there. Okay? Let's only look at one of them. Okay? The other ones you guys can look at that as exercise. Let me only look at this one here, for example, right? Only this one here. Okay. The visualization will be the same, right? You can see P1, P2, point V1, point V1. And also we got P3, point V2, right? The same. Let's reuse the diagram here. And now if I got assert equals P2, P3, okay, I'll write it down here. So here, so this one will boil down into P2 dot equals P3, right? So now in order to see which version of equals is going to be called, again, we have done this many times, we should look at the context object P2, right? And P2 has the dynamic type PV1. So that means the object version is going to be called. All right? That one's pretty easy. And on the other hand, if you look at the next one over here, right? Okay, next one. I can say a little bit more, okay, just in case, okay? If you look at the next one here, assert equals P3, P2. We simply swap the order of the argument, right? So let's say this one here is star, star, all right? So star, star over here. What would that boil down into? It's going to boil down into P3 dot equals P2. Now, which version is going to be called? It's going to be determined by P3's dynamic type. So if you look at P3 over here, its dynamic type is, according to the visualization, PV2. That means we're now going to call the overridden version. That's defined in PV2. The overridden equals from point V2 is called. That means we're going to just compare X with X and Y with Y, right? So you really want to compare and contrast this line here and also this line here. One is about P2, P3. The other one is about P3, P2. However, they're calling different versions of the equals method just because the context objects of the equals method call is different and their dynamic types are different, happen to be different. Does not need to be the same, but they might be different. Okay? Are we good? All right. Yeah, even though the JUnit assertion here is not really covering tomorrow, but you really want to catch up, right? Maybe over the weekend. So these are very important stuff. Otherwise, you will get also lost for the subsequent lecture later. Okay? We still got about 8 minutes. I think we can go over more examples, just to emphasize your understanding. But interrupt me if you got any questions. Okay? Right. So I think that we got just two more sets of examples. I can at least hopefully finish about the points. And then next Tuesday, we don't have class, right? It's Canada Day. So hopefully everybody can recharge, okay? And then on Thursday, we're going to resume our lecture. I will definitely finish off this lecture here. I'm going to start with something light. And then after that, we'll do inheritance, right? That will be the plan. Okay, let's now do this one here. We're just basically applying what we have learned so far. So let's do this one together. You can also find that in the slides, right? So P1 and P2. So we got point V1, point V1. Dynamic type, point V1, point V1. Okay? So we got 3, 4, and also 3, 4. Okay? 3, 4, and also 3, 4. Okay? Easy thing to check. So now, here's a question. Should this assertion pass or fail? First of all, what's P1 equals P2? False, right? Should that fail the assertion or pass the assertion? Pass, because we are asserting false, right? That's deliberate, okay? So here, P1 equals P2, we know that it's false, but that's okay because we are asserting false. So it will be pass. Okay, similarly, if you do this one, P2 equals P1, also false. Also, we are asserting false, right? Just notice that, okay? However, if you say assert same here, that's going to fail. Because assert same, P1, P2 is going to boil down into P1 equals P2, which is false. It's going to cause the assert same to fail. All right? Okay, you can see all sorts of possibility over here that you want to watch out for, okay? Okay, it's going to fail. All right, and then let's now do this one here. Let's say P1 dot equals P2. Just do this one here. Now, just this expression alone, is it going to be true or false? P1 dot equals P2. Which version of the equals method is going to be called? From objects or from some other class? What should we look at? Context object P1. Dynamic type, point V1. So that tells us this is dynamic type. The object version is going to be invoked, which boils down into P1 equals P2, which is false. And then we are asserting false, so it's going to pass. Right? You can see there are different layers of the result you have to watch out for. All right? And similarly for this one here as well, because P2 has the same dynamic type, just point V1, so the same argument. Okay? Just make sure you know how to explain this kind of a thing. And the final line here, just to say, if we want to compare contents for point V1, the best we can do is by calling the X and calling the Y on the individual argument, just to compare, right? Yeah, so the first page here is quite nicely, compare, assert false and also assert the same, right? It's just more example there to show to you. Okay, next one. Okay, at least one more. What about this one here? So let's say we got point V2. So let's say we got P3 and P4. Okay, dynamic type in this case would be point V2 and also point V2, right? So we got 3, 4, and also we got 3, 4 over here. All right. So this will be the dynamic type for P3. Right. This one here about comparing equals and also assert same. The same as last page. I'll leave that to you. Okay. Let's now take a look at just this one here. When I say P3 dot equals P4, right? Similarly, we know that it's going to be boiled down into P3 dot, beg your pardon, not boiled down into. It's simply P3 dot equals P4. So once we know that, we should look at the dynamic type for context object P3. And that one there you can see is now a different class, right? Point V2. So that tells me that the point V2 overridden version right here is going to be called. So point V2 version is going to be called. And that one there is simply eventually going to compare X with X and Y with Y, right? X and Y, they are simply the same. So the equals method here is going to return true. And then you assert true about true is going to pass, right? And exercise for you to think about P4 dot equals P3, right? This one here. P4 has the same dynamic type, so similar argument. Okay, final one. This one here is interesting, which we also mentioned briefly in the class before. Let's now make it more interesting here. We got P1 and we got P2. And notice that their dynamic types are different. We got point V1 and point V2, right? Different dynamic types. So think about here, we got point V1, 3 and 4. So this is the dynamic type for P1. And also we got point V2 over here. So that's the dynamic type, which is 3 and 4 over here. All right. Let's now talk about the actual assertion very quickly. Let's say if we say P1 dot equals P2. P1, what would be the difference? If I say, okay, make it bigger, P1 dot equals P2 versus P2 dot equals P1. Are they going to give us the same result? Or more precisely, are they going to call the same version of the equals method? Right? That's something you want to watch out for. So for the first one there, P1 has the dynamic type, point V1. So that means we're going to call the object version. And when you call the object version, it simply boils down into P1 equals P2. Right? However, notice one thing over here. It boils down into, right? So this is something Java behind the scene will compare for you. But if you write P1 equals P2 directly yourself, because P1 was declared as a different type as P2, so they wouldn't compile, right? That's something we actually said earlier in the class, right? Look at this comment more carefully, please, all right? That one I'll leave to you. We did discuss that earlier in the course, right? So this one here is just going to be false. Okay, it's going to be false, so that's why we assert false. Okay, bear with me, 1 minute, I'll finish this, and then I'll recap, and then we're done. Okay, what about this one here, right? I can tell you that this P2 that equals P1 is also going to give us false. However, it's actually going to give you false for a different reason. That's why we got to explore this 100%. Okay, so this one here, if you look at P2, what's its dynamic type? Right here. Point V2, right? So that means we're going to call the point V2, right? So the point V2, oh, sorry. If you don't mind, let me change the color here. Okay, P2 here, okay? It's going to call the point V2 version. Is going to be called, right? And now you can see that P2 and P1, we're comparing apple with banana, right? Which phase is it going to fail? Point V2. Is it going to fail on phase number 1? Not really, because they are different objects. So we don't really return true right away. Also, the second, the argument over here, the obj, P1, is actually not null. Also, we don't really return false right away. It's really this part over here is going to fail. Okay, I'm going to annotate a little bit, so you guys want to make sure you study that. Bear with me. So think about P2 over here and P1, right? So that means when we reach this line over here, okay, I'm going to draw some very explicit connection for you guys over here. So think about this part, this line here. This line over here is going to connect to right here. Okay, let's see. So now if I have, so this over here would be P2. And the obj over here will be the argument, which will be P1. So I'm really comparing P2 that get class, which will be point V2. P1 that get class, which will be point V1. They are not the same, which means we're going to return false right away. We don't really reach phase number 4. So it is very important when you study this example here, compare these two lines. They both return false from the equals method call, but for different reasons. Especially for the second one, it's going to return false because the two argument of the context object and argument here have different dynamic types. All right? Any questions? Okay, maybe I don't want to drag your fellow student any longer. I can handle off maybe after class. I appreciate it. Okay, well, I don't see you next Tuesday, but I'll see you tomorrow in the test.